Welcome everyone to our area activity involving triangles. So what you're going to need for this activity is a rectangular item that you can cut and write on. So you can go ahead and use just a regular old sheet of paper if you wish. You can use index card of various sizes. So you can use a 4x6, a 3.5 by 5, or a 3x5, I'm sorry. And I like to use a 5x8. So that's what I'm going to be using for this activity. The other things you'll need a straight edge to draw a line. You'll need some scissors to do some cutting and something to write with to draw some straight lines and maybe find the area of our rectangle and triangle. So those are the supplies you need, so go ahead and grab those. Alright, once you have your rectangular piece of paper or index card, what I'd like you to do is go ahead and label the base, the height, and then go ahead and put these little squares in the corners. Again, the corners in geometry, those are called vertices, so for each vertex, draw a little square. That means we have 90-degree angles at each of these vertices. So go ahead and take a few seconds to do that. Alright, the next thing I want to do is let's go ahead and find the area of this rectangle again. So the area of a rectangle is equal to the base times the height. So we have a base of 8 inches multiplied by a height of 5 inches. So base of 8 inches, height of 5 inches, 8 times 5 gives us 40. And our units are going to be square inches. So if we took 40 little squares that were 1 inch by 1 inch, we would be able to fit 40 of those inside this rectangle. Alright, so now that we have the area of the rectangle, let's go ahead and make a triangle. So how I want you to make a triangle is to go ahead and pick a point along the top side, the top edge of this rectangle. To the left or to the right of the center kind of works best. You could do it way on the sides, but really towards the middle is most effective. So go ahead, pick a spot, and what we're going to do is we're going to draw a line from that point to one vertex, and then we're going to draw another line from that point to the opposite vertex, and you'll see that we are going to make a triangle. So going ahead and doing that, we will form our triangle. And notice we actually formed 3 triangles. The one I'm most interested in at this moment is this larger one here. Now if you can, think about, make your best estimate, your best guess. What is the area of this bigger triangle? So the area of the entire rectangle is 40 square inches. What is your best guess at the area of the bigger triangle here? Alright, so let's actually do some cutting and see if we can find out the area of that bigger triangle by manipulating our pieces. So I already cut these out, so go ahead and cut along those lines. So you should end up with 3 triangles. And I did that already. So here is the larger triangle, and then here is the smaller one for me on the left. Here's the piece on the right, and notice I do have my rectangle here again. Altogether, this rectangle has an area of 40 square inches. Alright, now what I would like you to do, take these 2 smaller pieces here and see if you can manipulate them in some way to form another shape. Like put them together in a certain way, see if you can make another shape. So take a few seconds, see if you can do that, see if there's any relationship between these 2 shapes, these 2 smaller triangles, and the larger triangle. All right, what you may or may not have noticed is that if you take these two smaller triangles and you rotate them towards the middle, you end up with an exact replica of the larger triangle. So now what I've made is I've made two identical triangles. Two identical triangles. The original larger one, and then the second larger triangle, which was made up of those ones we cut out. So that tells me that the area of the entire rectangle was 40 square inches. What is the area of each of these larger triangles? What's the area of this larger triangle if it takes two of these larger triangles to make that one rectangle? Well, that would mean that if it takes two of these, that it should be half, right? So this should be 20 square inches and this should be 20 square inches, this entire triangle here, to make that 40 square inches of the rectangle. Well, let's go ahead and see if we could figure out how we could compute that using a formula. All right, well, we know that the area of the rectangle, so the area of the entire big rectangle is the base times the height. Now, it takes two of these big triangles to make a rectangle, so the area of this triangle has to be half of the rectangle. So we can take the area of the rectangle, divide it by 2, and that's going to be the area of this triangle. So let's go ahead and say the area is equal to the base of 8. Now we need to multiply it by the height. Now we know from our work before that the height needs to be at a 90-degree angle of the base. So the height is not going to be this side on the left, it's not going to be on this side on the right, because they don't make 90-degree angles with the base. But if you remember, when we cut out these pieces, the height of the rectangle was 5 inches. Well, if we take it and we rotate it in to make that identical triangle, what do we have as the height? The height of the triangle, so I'm going to go ahead and draw that in the best I can here. The height of the triangle at a 90-degree angle is 5 inches. See how that works? So we have our height is also going to be 5 inches for the triangle, just like the rectangle. So that means that's 8 times 5 over 2. And we know that that is 40 over 2. So the area of this triangle, just like we thought, is 20 square inches. And if the area of this triangle is 20 square inches, and the area of the identical triangle made from the two other pieces is also 20 square inches, then we get the area of the entire rectangle, which we have before, as 40 square inches. Now, one last thing I did want to show you, it's kind of fun, is we know before that our work with our rectangles, that if we took a slice of the rectangle off of one side and we slid it to the other side, we would get a parallelogram. So if I take the piece that I cut off on the left, I slide it to the right, notice what do I get? I get a parallelogram. And if the area of this triangle is 20 square inches, well, that means the area of the identical triangle, it's just flipped here, is also going to be 20 square inches, so the area of the parallelogram is 40 square inches, just like the rectangle. All right, well, I hope this hands-on activity has given you a visual of how we come up with the formula for the area of a triangle. And the area is the base times the height divided by 2, because a triangle is half of a rectangle, or you could even say it is half of a parallelogram.